Hey, what's up, Algebra 2? It's Ryan. I'm back again with solving radical equations. In our last lecture, we went over some of the steps involved in solving radical equations and sort of how to approach them, and also how to avoid extraneous solutions. So if you have not watched that lecture, just go back, find it, and you can sort of go through it and learn with me. And today, in today's video, we're going to just get more practice with it. So I have these 8 questions, and we're just going to go through them using some of the techniques we talked about in the last lecture. Okay, so in number 1, we want to isolate the radical. So we need to first subtract this 7. We need to add this 7 to both sides. So we do plus 7, and we get 8 root 10x equals 9 plus 7, which is 16. And when we divide both sides by 8, we get root 10x equals 2. Now when we square both sides, right, because squaring gets rid of this radical, we get 10x equal, oh, that looks like a 3. I think I need to go back, I'm sorry. When we square both sides, we end up getting 10x equals 4. We solve for x by dividing both sides by 10, and we get x equals 4/10, which is the same thing as x equals 2/5, or 0.4. So now let's plug this in, because we do need to check our answer to avoid extraneous solutions. So 2/5 times 10 gives us 4, right? 4/10 times 10 gives us 4. The square root of 4 is positive 2. X times positive 2 gives us 16. 16 minus 7 gives us 9. So this works. Now let's move on to number 2. So we first want to isolate this radical. We add 6 to both sides, and we get the third root of 4x plus 2 equals negative 10 plus 6, so we get negative 4. Now we want to cube both sides. Sorry, that looks weird. And so we end up getting 4x plus 2 equals negative 4 cubed. It's going to be negative 64, because negative 4 times negative 4 is positive 16, times negative 4 is negative 64. Now we just solve for x. We subtract 2 from both sides, so we get 4x equals negative 66. We divide by 4, and we get x equals, so 60 divided by 4, or negative 60 divided by 4 is negative 15, and 6 divided by 4 is going to be 2/3. So this is going to be negative 15 and 2/3. Or we can, it might just be better to write it as x equals negative 33 over 2. I think I prefer this answer. So now let's plug this in. So negative 33 over 2 times 4 is going to give us negative 66. Negative 66 plus 2 is negative 64. And negative 64, the third root of negative 64 is negative 4. Negative 4 minus 10, or minus 6 equals negative 10. So this works. Great. Now let's move on to 3. We want to isolate this rational exponent, so we first want to subtract 22 from both sides. And so we get 3x plus 43 raised to the 2/3 power gives us 38 minus 22. and that's going to give us 16. Yep, 16, sorry. For a second, I was just double checking. Okay, so now we want to raise, as I said before, to the reciprocal exponent. We talked a little bit about that in the last lecture. So that's going to be the 3/2 power. And so now on this left side, we're going to get 3x plus 43 equals, now 16 raised to the 3/2 power. We do the square root of 16 because it's raised to the 1/2, right? This 2 in the denominator. The square root of 16 is going to be 4, and 4 raised to the 3rd power is going to be 64. Now we solve for x by subtracting 43 on both sides first. And when we subtract 43, we get 61/21. And then when we divide by 3, we get x equals 7. And so when we plug in 7 into this original equation, we get 3 times 7, 21. 21 plus 43 is 64. 64 raised to the 2/3 power. Well, we do the 3rd root of 64, which is going to be 4, and 4 squared, which is positive 16. So we do positive 16 plus 22, and that we get 38. So this checks out. By the way, if I'm going kind of fast, pause, digest what I'm saying, rewind, listen to it over if you want to. And yeah, if you do have questions about what I'm doing, of course, reach out. Okay, so let's now work on number 4. We want to isolate this rational exponent, so we first have to divide by 9. We get x to the 2/5 equals 36 divided by 9, which is 4. So now we want to raise to the reciprocal exponent, which in this case is going to be 5/2. So we get x equals 4 to the 5/2 power is going to be the square root of 4 because we have a 2 in the denominator, which is going to be positive 2, right? We assume it's positive 2. And 2 raised to the 5th power is going to be 32. So now let's just plug this in. 32 to the 2/5 power. Well, we take the 5th root of 32, we get 2, positive 2. And positive 2 squared is going to be 4. And 4 times 9 is going to be 36. So this works. Okay, great. Now let's move on to 5. So we have this radical isolated already, so we want to square both sides. And so when we square the left side, we get, and you can FOIL this out, but we're going to get x squared minus 12x plus 36. And when we square this side, we just get rid of the radical, so we get 3x. Now we want to move 3x to the other side, so we're going to do x squared minus 15x plus 36 equals 0. Now we want to sort of factor this. So we want to think of two numbers that multiply to positive 36 and add to negative 15, and that's going to be negative 12 and negative 3. So we're going to do x minus 12 and x minus 3 equals 0. So we set those parentheses equal to 0, and we get x equals 12 and x equals 3. Now we need to plug these back into our original equation. So when we plug in 12, we do 12 minus 6, and we get positive 6. Now 3 times 12 for the right is going to be 36. The square root of 36 is going to be positive 6. So this ends up working. Now let's do 3. 3 minus 6 is negative 3. And so since this already is just a radical, I know it's going to be extraneous, but let's go through again. So as I said before, 3 minus 6 is negative 3. And we take 3 times 3 is 9. the square root of 9 is going to be positive 3, and positive 3 does not equal negative 3. We assume that this root is positive, and that's what's going to make this extraneous. Great. Okay, let's do number 6 now. So in this case, we want to move this cube root of 8x plus 15 to the other side, such that we get the third root of 12x minus 5 equals the third root of 8x plus 15. We have the third root on both sides, so this actually isn't that bad. We raise both sides to the third power, and we end up getting 12x minus 5 equals 8x plus 15. Now we just solve. I'm going to do 2 steps at once. I'm going to subtract 8x from both sides, so we get 4x. I'm going to add 5 to both sides, so we get 20. We divide by 4, we get x equals 5. Now we plug this back in. Sorry, I'm kind of speed running this. We get 5. 12 times 5 is 60. 60 minus 5 is 55. Then we take the third root of 55. I'm not going to do that, but we end up getting the third root of 55 for that first term. Now we plug in 5 again. 8 times 5 is 40. 40 plus 15 is 55. So we take the third root of 55. Now, the third root of 55 minus the third root of 55 is going to be 0 because they're the same value. So that works out. Okay, last 2. Now, this one's going to be hard because, as I said before, when we did this in the last lecture, we have to do it twice. So we square both sides, and you can FOIL this out, but eventually we're going to get 3x minus 8 plus 2 root 3x minus 8 plus 1 equals x plus 5. And go to the other video to see how I, or you could just sort of look at what I did here. Sort of see how I squared this term when I had this radical. You treat it the same way. But yeah, you FOIL like this. So that's essentially what I did right here. And for the right side, I said it was equal to x plus 5 because squaring the radical just cancels each other out. Okay, at this point, I'm just going to combine like terms on the left side and then move them to the right side. So we get 3x minus 7 plus 2 root 3x minus 8. That's equal to x plus 5. So I'm going to move these x's and this 7 to the other side. So I subtract 3x from both sides. I'm going to end up getting, 3x minus 8. I subtract 3x from both sides, we get negative 2x. And I add 7 to both sides, so we get 12. Now we divide by 2, and we get the square root of 3x minus 8 equals, I'm just going to say 6 minus x. Now at this point, we want to square both sides to get rid of that radical. So we end up getting, we end up getting 3x minus 8 equals x squared minus 12x plus 36. Okay? And again, just FOIL if you want to see how I got that right side. At this point, I'm just going to simplify, move everything to the right side, combine like terms. We subtract 3x from both sides, we get x squared minus 15x. Add 8 to both sides, we get plus 44. And now we look for two numbers that multiply to positive 44 and add to negative 15. That's going to be negative 11 and negative 4. So we get 0 equals x minus 11 into x minus 4. So we get x equals 11 into x equals 4. Boom. Now we want to plug in each of these answers. So we get 11 times 3 is going to be 33, minus 8 is going to give us, well, I said 33. Minus 8 is going to give us 25. Sorry, for a second I was tripping. It's like 1:30, so my mind's not at its peak right now. It's all right. So we ended up getting 25. The square root of 25 is just going to be 5. Positive 5, that is. And positive 5 plus 1 is going to be positive 6. Now we do 11 plus 5, and we end up getting 16. The square root of 16 is going to be 4. So we ended up getting 6 equals 4, which is not correct. So this is going to be an extraneous solution. Okay, so now let's plug in 4. 3 times 4 is 12. 12 minus 8 is going to be 4. The square root of 4 is positive 2. Positive 2 plus 1 is 3. Now we do 4 plus 5 is 9. The square root of 9 is going to be 3. So we get 3 equals 3. That checks out. So we know 4 works. Great. Now let's work on number 8. This actually isn't that bad. And you actually may be able to see this just from looking at it. But we have these two radicals on both sides. We want to get rid of it. It's sort of like we did up here, except they sort of did the first step for us. But we want to square both sides. And when we square both sides, we end up getting 2/3 x minus 4 equals 2/5 x minus 7. Okay? And now we we just want to have the, actually, how about this? Let's move all the x's to one side and all the constants to another. So we get 2/3 x minus 2/5 x. And then we get negative 7 plus 4, which is just going to be negative 3. Now we just need to add these 2/3 minus 2/5. Well, 2/3 is going to, is going to be equal to 10 over 15. We just need to find denominators. 15's the least common multiple of 3 and 5. So 2/3 is 10/15, and 2/5 is going to be 6/15. So we have 10/15 x minus 6/15 x equals negative 3. We subtract these two, we end up getting negative 4, not negative 4, my bad, positive 4, I'm tripping. Positive 4 over 15 x equals negative 3. So we multiply both sides by 15, we end up getting 4x equals negative 45. Well, it doesn't matter. Now we divide by 4, and we end up getting x equals negative 45 divided by 4. Now let's just plug this back into the original equation. So 2/3 times negative 45 over 4, that's going to be, if we just do some mental math, you probably shouldn't write this down. I might make a silly mistake. It doesn't matter. We end up getting 15 over 2. Let me just see. Yeah, 15 over 2 minus 4. 15 over 2 is 7.5. 7.5 minus 4 is 3.5. I'm just going to write that down. So the square root of 3.5. Now, negative 45 divided by 4 times 2/5. Well, that's going to end up being 9 over 2. Negative 9 over 2. Ooh, which, by the way, I'm sorry about that. This is not going to be 3.5. This is going to be negative 15 over 2, so negative 7.5 minus 4. And that gives us, what? Negative 11.5. I'm sorry about that. Okay, so we said this is 9 over 2, I believe. Or negative 9 over 2. So negative 9 over 2 is negative 4.5 minus 7. And that's going to, again, give us negative 11.5. Okay, so we end up getting the square root of negative 11.5 equals the square root of negative 11.5, which technically would sound right. However, we know that the expressions within or under the radical must be non-negative. So they must either be 0 or something positive. Obviously, both of these are negative, and since they're negative, it's going to come out to I. It's going to be a little bit tricky. So it's actually not. It's going to be an extraneous solution. It's not going to entirely work. So we're actually, for this answer, we're going to have no real solutions. No real solutions. Okay, great. So that's pretty much all we have for today. And solving radical equations and trying to avoid extraneous solutions. Again, if you have any questions about any of the stuff we went over today, I know it was just mostly practice. I'd actually first ask you to watch the lecture from before, and if you have any more questions and you want some one-on-one help, you can definitely reach out to me, talk to your teacher, go to the tutoring center, use your online resources, and yeah, just use other people in your class too. Okay, thank you. Have a good day. Bye.